Okay, we're just going to have a go at this question here, which puts together everything we've been doing in the last few videos. Okay, so if A, B, and C are the position vectors of the points capital A, capital B, and capital C, show that the area of a triangle ABC is given by this complicated looking expression here. Now the capital A, capital B, and capital C are the vertices of our triangle. So let's draw a triangle and let's label A, B, and C. Now remember, our area of a triangle formula is equal to half the cross product of A and B and the magnitude of that, where the A and the B are the vectors of two of the side lengths. So what we need to start figuring out is the vectors of two of the side lengths. So let's say I wanted to get from A to B. I would need to do the position vector of B, which is lowercase b, subtract the position vector of A, which is lowercase a. Okay, so that would be this vector here going from A to B. Now let's try and figure out another one. Let's say A to C. Well, for this one, I'd be doing the position vector of C, subtract the position vector of A. So that would be the vector going like that. And you can fill in the last one in a similar way. Let's say we were going from B to C. Well, then we would be doing C subtract B, like that. So now I can have a go at using my area formula. It is going to be half the magnitude, and then we just need to pick two of the vectors. It doesn't matter which two, as discussed in the previous video. So let's just go with the B subtract A, which I'll put in brackets because it is subtract, cross product with the C subtract A, which I'll also put in brackets like this. So we got ourselves an expression for the area, but it's not exactly what I want. So what I'm now going to do is use the distributive law to expand these brackets. Okay, so I'm going to do the B cross product with the C in that order. So B cross product C. And then I'm going to do the B cross product with negative A. So the negative I'll bring to the front, and then a B cross product with A. Now we're going to do the negative A with the C. So negative A cross product with C. And then finally the negative A with the negative A. So negative times the negative is positive, then A cross A. And then we will close our magnitude. Then we're going to simplify what's in there. So if we look, we have A cross A, that is equal to the 0 vector. So I could ignore that using one of our properties. So I'm just going to write in everything else we've got. And then if we compare what we've got with what we're aiming for, okay, what I can see is nothing I have there exactly seems to match other than the B cross C. Okay, that matches with this spot here, so I don't have to touch that. The other two parts of the issue, so we're going to have to investigate. We need A cross B. Currently, I have negative B cross A. While using our properties, I can swap our vectors around, providing I change the sign in front, our anti-commutative property. So become plus A cross B, and then I'm going to write subtract A cross C. So then we've got two parts matching now. Our only problem is the fact that we have this part here, negative A cross C. I want a positive C cross A. So I could do something very similar. I could swap our two vectors around, but I then just need to change the sign. So it would become positive, but it's going to be C cross A. Then I have pretty much what I want. Okay, however, I do just need to reorder it because our three vector products are being added and addition is commutative. I can shift them around. So I would write the A cross B first, then plus the B cross C, and then finally plus the C cross A as required.